first question is question 1. Question 1 is given a parametric equation of x and y. And the question A asks me to prove if dy per dx is equal to 2 plus 8 over t squared minus 2, with t is not equal to square root of 2. To solve this question, first we must find dx per dt by differentiate parametric equation of x. After that, we must find dy per dt by differentiate parametric equation of y. To obtain dy per dx, we must use chain rule, which is dy per dt is times with dt per dx. Then we can substitute dy per dt and dt per dx into chain rule. But for dt per dx, we can easily get from the dx per dt by change the position of dx per dt. Next, dy per dt, we can substitute directly without any change. After substitute, we can substitute into a chain rule. Then we can simplify it by cancel t squared. So it can obtain 2t squared plus 4 over t squared minus 2. From the answer, we know that it is a polynomial. Since the polynomial is higher than the denominator, so we use to factorize by using long division. As a final answer, we got dy per dx is equal to 2 plus 8 over t squared minus 2. So that dy per dx is proven. Now we move to the question 1b. The question asks me to find the equation of the normal to the curve when y is equal to 2 and give the answer in the form of a standard form. Okay, first step is we have to find the value of t since the question gives us y is equal to 2. So we have to substitute the y equal to 2 into a parametric equation of y. And we get the t value is equal to -1 and t value is equal to 2.
Christina, I want to ask, why we don't take t equal to -1?
It is because based on the question, it's already stated that the condition of t must be greater than 0. Since t is equal to -1 is less than 0, so we only take t is equal to 2.
Okay, thank you, Christina.
Okay. Then after we get t equal to 2, then we substitute into x parametric equation of x. And we get x equal to 3. From that, we can get one coordinate, which is 3, 2. Then we need to find the gradient by substitute t equal to 2 into dy per dx. And from that, we get value dy per dx is equal to 6. After that, we have to find the gradient for the normal equation. The gradient for the normal equation is equal to -1 over 6. After that,
Christina,
yes,
why the gradient for normal equation is equal -1 over 6?
it is because the gradient dy per dx is equal to 6 is the gradient for the tangent. But for this question, we need the normal gradient for the normal equation. So we must use formula m1 times m2 is equal to -1. Then we can substitute m1 with 6 and simplify to get m equal to -1 over 6. Is it clear?
Okay, thank you.
Okay, now we have a m and a point. So we can substitute the gradient and the point into a point slope equation, which is y minus y1 equal to m plus x minus x1. Then after substitute that, we get a value of y equal to negative 1 over 6x plus 5 per 5 over 2. But we have to change the answer into this form. Okay, then after change, we get the answer 1 over 6x plus y minus 5 over 2 equal to 0.
Okay, so we move on to the next question. Question 1c. Find second derivative d to y dx squared in terms of t. Okay, so this is the formula for second derivative d dt in bracket dy dx times dt dx. Okay, first of all, we just substitute the value for dy dx and dt dx in the formula. Okay, for to differentiate the value of 8 over t squared minus 2, we need to use quotient rules because it is in the division form. So, we let u equal to 8 and we got u prime equal to 0. V equal to t squared minus 2 and we got v prime equal to 2t. Okay, next, we differentiate 2, we got 0, and differentiate this in quotient rule. We use the formula u prime v minus u v prime over v squared and times t squared over t squared minus 2. Okay, so use next, simplify this operation, and we got the answer is negative 60 t cubed over t squared minus 2 cubed. Okay, next is question 2a. An ellipse has length of the minor axis is 4 units and the foci at 2 plus sub 5 negative 2 and 2 minus sub 5 negative 2. The question is find the center, measure vertices and the general equation of the ellipse. Okay, next we are given the value for foci, which is f1 2 plus sub 5 negative 2 and f2 2 minus sub 5 negative 2. We are also given the information about the length of minor axis equal to 4 units. As we know, the length of minor axis is equal to 2b. So 2b equal to 4 and we get the value for b is 2. And we also get the value for c equal to sub 5 from the foci. Since the formula for foci is h plus minus c k. Okay, the center also we got the value from the foci since the value of the foci is h plus minus c k. So we just take hk. So the center is 2 negative 2. Okay, since we have the value for b and c, we need to know what is the value for a to find the major vertices. The value for a, we used the formula a squared equal to b squared plus c squared. So a squared, we just substitute b equal to 2 and c equal to sub 5. And we get the value of a squared equal to 9. And we get the value of a is equal to plus minus 3. So major vertices is A is the value from center to major vertices. So we just add positive 3 and negative 3 into our center. So 2 plus 3, negative 2, 2 minus 3, negative 2. So we get the value for major vertices is 5, negative 2, negative 1, negative 2. But the last question is general equation of ellipse. First of all, we need to substitute the information of ellipse into a standard form. So we get the x minus 2 squared over 9 plus y plus 2 squared over 4 equal to 1. Okay, next we expand it and we get x squared minus 4x plus 4 over 9 plus y squared or plus 4x plus 4 over 4 equal to 1. Next we do the cross multiplication and we get the answer is 4x squared minus 16x plus 16 plus 9y squared plus 36y plus 36 equal to 36. And the general equation for the ellipse is 4x squared plus 9y squared minus 60x plus 36y plus 16 equal to 0.
Next question, we need to determine the parametric equation of the ellipse in terms of t. So first of all, we need to find the standard equation of an ellipse. This is the standard equation of an ellipse. From previous question, we have find the value of A equal to 3, B equal to 2, K equal to negative 2, H equal to 2. So we need to substitute the value in the standard equation. So we have bracket x minus 2 bracket square divided by 3 square plus bracket y plus 2 bracket square divided by 2 square equal to 1. We have the cos square t plus sin square t equal to 1. This is trigonometric identity. So we can compare this identity with standard equation. Therefore, we have the bracket x minus 2 bracket square divided by 3 square equal to cos square t. We need to square root both sides. So we have x minus 2 divided by 3 equal to cos t. So we need to multiply with 3. We have 3 minus t equal to 3 cos t. So we have the parametric equation in x in terms of t is x equal to 2 plus 3 cos t. We use the same step when we find the parametric equation of the ellipse of y in terms of t. So we need to square root both sides. We have y plus 2 divided by 2 equal to sin t. We need to multiply with 2 and then we get y plus 2 equal to 2 sin t. So the parametric equation of ellipse in y in terms of t is y equal to negative 2 plus 2 sin t. So the parametric equation are x equal to 2 plus 3 cos t, y equal to negative 2 plus 2 sin t. The last question is we need to sketch the graph of the ellipse by using the information and the value from previous question. We can sketch the graph of the ellipse. First of all, we need to sketch x and y axis. The major axis is the longest axis of the ellipse and the minor axis is the shorter axis of the ellipse. So we have the value of C from the previous question, which is C is 2, negative 2. So the question given the information about F1 and F2. F1 is 2 plus square root 5 negative 2 and F2 is 2 minus square root 5 negative 2. So the distance between center and major vertex is 3. So the coordinate of major vertex V1 is 5, negative 2 and V2 is negative 1 and 2. So we have the VM1 equal to 2, 0 and VM2 equal to 2, 4. Anyone have question?
I have a question. How do you find the coordinate for minor vertex?
The question given information about the distance minor axis is 4. Minor axis is 4, so we need minor axis is VM1 until VM2. So distance between VM1 until VM2 is 4. So we need to find the distance between VM1 until center. So we need to divide by 2. So we get distance is 2. So we get the coordinate of V1. Are you clear?
Yes, I clear with that answer.
Okay, this is the graph of the ellipse. So that's all for me. Thank you.